So good afternoon, everyone. Thank you for being here. My name is Wojtek Piaseczny. I'm on the Amazon RDS team. Specifically, I'm responsible for the RDS SQL Server and RDS Oracle services. Joining me here is Veronica Durgin. She's a manager of data services at Sonos. If you're anything like me, you're already a fan of Veronica's because your house is full of her products and you're enjoying it. So I know that we're the last thing that's standing between you and the replay party tonight, so hopefully we'll have a good time together. Just by a show of hands, how many of you are already running SQL Server on AWS? Okay, how many of you, why don't you keep your hands up, how many of you are familiar with RDS? And how many of you are running RDS? Okay, so a pretty good distribution. Thanks, that helps me understand where we should spend some of our time. So let's get right into it. Why are customers, or why are you running things on AWS? There's a lot of you that are already doing this, so you already know these reasons, but there's some folks here as well that are still trying to make these decisions, so we'll go through this quickly at a high level and then move on to some of the optimization things we want to get into. People are running their SQL Server workloads not in isolation, but in general as part of their application stack. So why are customers running their application stacks in AWS? Well, the agility is a huge thing, being able to spin things up quickly, test out ideas, either succeed quickly, which is fantastic, or fail quickly, which is also fantastic, and in many cases even more valuable. The breadth of services that we offer is something that customers often tell us they enjoy. We're launching more and more services every reInvent, not just reInvent, throughout the year. There's some that were launched this week that are probably of particular interest to this group around things like Amazon FSx. The next is cost. Cost is often a thing that comes up in these conversations. It's an important enabler for customers to be able to trade some capital expenditures for variable expenditures, and then at the scale that we operate at, generally speaking, we're able to do these variable expenditures at a better price point than you might be able to do for yourself. The next thing that I think about anyways is the ability to deploy globally. So we're getting into a world where data sovereignty rights and things of this nature are becoming more and more impactful in the decisions that we're making on a daily basis. So being able to configure your workloads and then deploy globally in minutes is a huge advantage. And then finally, the elasticity. So once you are in there and you're running and you have a spike for your traffic for Black Friday or tax season or whatever the relevant events are for your business, you can quickly scale up and down to your needs, and obviously you're only paying for what you're using. So let's talk a little bit about Microsoft or Windows workloads in general on AWS. So we talked about the breadth and acceleration of our feature velocity. That's certainly clear in the Microsoft space. So, going back to 2008, we obviously have many features that we've delivered to support Microsoft workloads. The things that are I'm not going to go through all the bullet points, but you can see that there is an accelerating trend to these deliveries, and there's things on there that you would expect, support for the Windows versions and the SQL Server versions and all of that kind of stuff. But then as we've moved through time, we've heard feedback from our customers and reacted to it by offering higher level services, so like managed services for Active Directory or managed services for databases like RDS. We have a plethora of licensing options. I know this is a SQL Server talk, so we will talk about licensing because it's a SQL Server talk. So we do have a bunch of different licensing options across the various services that we offer as well. So we talked a little bit about why you're using AWS. Let's get more specific into SQL Server. So let's look at the design aspect first, and then we'll talk about migration and management. So where can you run SQL Server in AWS? The first thing to think about is the management model. So we have two management models. One is a self-managed service, and that's on our virtual machine platform called EC2, where you're responsible for a lot of the things that you might be responsible for on-premise. We take care of everything from the host operating system of the virtual machine down from there. That includes things like physical security to our data centers and isolation of storage, isolation of networks, things of that nature. But everything from basically Windows and up, you would be responsible for. In RDS, we change that responsibility model where we actually take more responsibility within AWS to do things for you. So let's look at some of those things that we take responsibility for when you choose to run in RDS over EC2. Well, maybe I'll start with a story around this. When I talk to a DBA, or even in my previous lives, I ask them where they want to be spending their time. And they're telling me about interesting data analytics or insights into their application or tuning queries that are causing them whatever sorts of production issues. I say, that sounds fantastic. And then I ask them where they are spending their time. And they tell me, well, the backup didn't run properly last night, so I was up all night doing that. And we had a failover the other day, so I had to rebuild the secondary node, and that wasn't so awesome. And then I had to upgrade the database and the operating system. And there was all of these things that were highly tactical, like super important. They have to get done, don't get me wrong. But they weren't in any way differentiating to these people's business. They were just things that have to get done. So in RDS, that's the value proposition we offer. We take care of the undifferentiated heavy lifting so that you can focus on the things that actually matter to your business. There is an important call out. So I'm from the RDS team. I like to be, I'm obviously biased. But there are a couple of call outs that I think are super important to say about RDS. There are things that we prevent you from doing so that we can live up to the promises that we make. So for example, we don't give you SA access, which means you can't run SharePoint because SharePoint needs elevated access to run things like the index service. There are a few other applications like that. So we love to hear feedback around these kinds of things. We don't restrict your access because we're selfish and we want all the access for ourselves. We restrict it so that we can live up to the promises that we're making around our service. So in a lot of cases, we're working with customers or even partners. We'll talk about one of them a little bit later, SentryOne, where a customer has a use case where they need some slightly elevated permissions. We didn't know that they would be useful to someone, so based on that feedback, we were able to go in and enhance that. One thing that's consistent across both EC2 and RDS is that application tuning, application optimization, all of these things, they remain your responsibility. So it is important to have in-house expertise around databases because we've seen a couple cases where customers assume that because you're running in RDS, you don't need to have a database administrator. That's probably not the right way to think about it. The right way that I've heard from some customers is that they've just been able to elevate the role of their database administrators into spending their time where they want to be spending their time, into application optimization, data insights, things of this nature, and sometimes even changing the role. A customer was just telling me the other day they changed their database administrator title to database advisor to reflect the new responsibilities that they were taking on in this type of world. All right, so we've talked a bit about the management model. So many of the things we'll talk about here are going to be largely consistent between between RDS and EC2. There are slight variations in things like instance types that might be available on one versus the other. I'll try to call that out, but at a high level, there's a lot of similarities here, and so I don't want to spend too much of our time just focusing on those nuances. So within the management model that you choose, you still have a lot of control over variables that impact things like the performance, the cost, the maintenance, the availability of your database. So let's start with the operating system. We'll go from there, we'll go down from there, and then we'll come back up and look at some deployment architectures for SQL Server itself. Starting with SQL Server 2017, as I'm sure you all know, Microsoft started supporting SQL Server on Linux, which is fantastic. We've heard two primary reasons for customers to be interested in SQL Server on Linux. The first is obviously cost. So running on Linux, you eliminate the Windows cost. Loosely speaking, we hear that that's about 10% of the total cost of ownership. So it's nice, don't get me wrong, I'd love to save 10% every time. But we haven't seen that cost to be a huge sort of forcing function for customers to go and actually make a migration to Linux. And then the other reason that we've heard is consistency of managing environments for customers. So as things are becoming increasingly Linux-based anyways, if customers have Linux-based application stacks, it might be easier for them to manage their whole application stack when it's all running on Linux, just to eliminate some differences that they would otherwise have to account for from operating system installation, patching, etc. Perspectives. So when we first heard about SQL Server on Linux, we were like, this is fantastic, but is it real? So, and what I mean by that is like, is it performant? Is Microsoft invested in it? Do we believe that this is a thing that customers are really going to love? And by and large, I think the answer is yes, at least from a performance perspective. So we ran our own benchmarks and found that SQL Server on Linux was performing within about 10% of what we were throwing at it on a comparable SQL Server on Windows workload. There are some things that don't work yet with SQL Server 2017. Microsoft maintains that list. I think at SQL Pass earlier this year, they announced that in 2019, they intend to have full feature parity between SQL Server on Linux and SQL Server on Windows. So I do believe that Microsoft is serious about this and will continue to invest in this offering. So we have this available in Amazon. We have several Amazon machine images across a flavor of different Linux distributions. So this is fully available, fully supported in Amazon as well. This is only available in EC2. This is not available in RDS. All right, let's start going down below the operating system into some of the compute resources that you can be looking at for your SQL Server workloads. Obviously, every different type of workload has different requirements for CPU, for memory, for networking, et cetera. In Amazon EC2, what we did is identified these workloads and built instance families for each of these purposes specifically. So what you'll see is many different types of instances available from EC2, but they may not necessarily be targeted at SQL Server workloads. So what I want to do, instead of talking about all of them, is just talk about the ones that we think are really the most common or popular for running SQL Server. The first I'll mention is the M4 family, or the M family. The M family has a good balance of memory and CPU. So this is one where we call it the general purpose family, and much of our workloads are actually running on the M family today. The next one is the T family. So the T family has similar ratios of memory to CPU as the M family. It's at a lower price point because it has bursty performance. So typically we see things like dev test workloads or just lower throughput workloads in general running on the T family. The next thing I want to point out is the memory optimized family. So there's a whole bunch of these. These are the X families and the R families. SQL Server, again, being a licensed software product, you're licensing the CPUs. So what we typically see is that the deployments become memory bound. So customers want as much memory as they can get for as few CPUs as they can get. So that's where we see the memory optimized family being really suitable and actually are most popular for what we think of as our production workloads. And then finally, I'll mention one other, which is the i3 family, which has the same memory to CPU ratio as the R family. The difference being that it also has a lot of locally attached NVMe storage. We'll get into that a little bit further in the presentation. So I wanted to dive into one particular instance family just to sort of show you the breadth of power and performance that you might expect out of any one of these instances. So the R5D, first thing I'll call out is you'll notice the D. The D generally means that there is locally attached NVMe storage. And so that's going to be super high performance storage, but it is locally attached. We'll get into the differences between that and some other storage offerings shortly as well. So within the R5 family, you've got a lot of variety. You've got, you can go down from 2 vCPUs all the way up to 96, and similarly on memory from 16 gigs up to over 700. So that's super exciting, but again, licensing. So you might be saying, hey, I would love to have those 384 gigs of RAM, but I really don't want to pay for 48 cores of SQL Server licensing. So that's feedback that we've heard, and that's why we built a feature called Optimized CPU. So what Optimized CPU does is lets you control the number of active CPUs that you have on your instance, as well as the status of hyperthreading. Let's go through an example to just sort of explain what exactly or how exactly this might help. So let's talk about a workload where you need to have 8 vCPUs, but you need more memory than would come with 8 vCPUs on the R5 instance. I think that number was 64 gigs. So the next two instance sizes larger are the R5 4XL and R5 12XL, and they go from 16 and 48 vCPUs. If you're purchasing that instance and running all of the CPUs and licensing all of those CPUs, you're paying a lot. If you disable a bunch of those CPUs, in the case of the R5, you can save about 83% on the SQL Server licensing, and in the case of R4, you'll save about 50%. So obviously this depends on your workload. We'll have a couple themes in this conversation. One of them is going to be testing. So this is a case where it's really easy to test. We talked a little bit about agility. Figure out, like as I'm sure you're already doing, figure out what your throughput requirements are, what your bottlenecks are, and then you can start optimizing with things like optimized CPU for various, whether it's performance or whether it's licensing in this case. So how do I use optimized CPU? It's simple. It's two things. So we basically added two parameters to our APIs to let you pass in those two things. The call out that I want to make here is that this is only available when you're creating an instance. So you can't on the fly add a CPU or take away add an active CPU or take away an active CPU. So if for example, like continuing our previous example, you took a machine and you only enabled 8 active vCPUs on it, and then you decided, actually I needed 10. You can't just go to that machine and add 2 more. What you need to do is create a new machine and migrate to it. And we did that for a very good reason. It's because we needed this to be hard partitioned for you to actually be able to realize the licensing savings behind this. So I've talked to you about a theoretical example around, how did we do the math in terms of coming up with this feature, and how much money do we think it'll save you? This is a quote from a real customer, Cloudhesive. They actually specialize in helping customers optimize their spend, and they're seeing 50% as a real savings number in their workloads. All right, so we've talked a little bit about the compute options that are available for your deployments. Now let's get into the storage options. AWS has a lot of storage options. Similar to the compute things we were talking about, these things are built with specific workloads in mind. So rather than talking about all of them, we're just going to talk about the ones that I think are most relevant to SQL Server deployments. That'll be EC2 Instance Store as well as the Elastic Block Store. And that's where we're going to run our database. We'll also talk about Amazon Simple Storage Service, or S3, in the context of backups. So what are the things to think about when you're deciding where to put your storage? I think of 2 categories, and within the first there's a couple. So where are you going to put your data files? Where are you going to put your log files? Where are you going to put your backups? So again, depending on the characteristics of your workloads, you may need super fast log performance, especially if it's a write-heavy application. If you don't necessarily have a super write-heavy application, then the storage characteristic performance of your data and your log files might be fine if it's the same. And then for backups, this isn't on the critical path for the performance of your database. This is a thing that needs to be available and durable. Of course, it has to be performant enough to actually consume your backup or to accept your backup. But this isn't critical path query processing that you have to have super high performance for. It's really a case where durability is the key. I think in this morning's keynote, there was a lot of talk about the design of S3 and how they achieve durability. So hopefully that was insightful in pointing at this as well. So I told you what you should use, but I didn't tell you anything about them. So let's back up to there a little bit. So Amazon EBS is our network attached storage service. It comes with a lot of really good features. Obviously, it's one of our services, so you only pay for what you use. It has built-in redundancy. So every time you have an EBS volume, there's actually 2 drives behind that. And when you write something, it synchronously writes across these 2 volumes. So that helps you achieve better availability and durability because these things are ultimately just storage volumes, and these things do fail. So when one of those things fail, if we can just sort of handle it at the infrastructure level, that doesn't come up and impact SQL Server or ultimately the application that you have sitting on top of it. In addition to that, there's a few features that I think are worth calling out in context of SQL Server. The first is encryption at rest. So many customers are using Enterprise Edition. One of the reasons that we hear a lot is because they're using transparent data encryption, an enterprise-only feature. With encryption at rest, at an EBS level, you actually get all of that same security, all of the same capabilities, but you can do it on anything. You can even do it on like Express Edition if you wanted to. So that's definitely a neat feature. The other thing that I wanted to call out was the flavors of solid state drives that we have. So in EBS, there's 2 flavors of that. They're called IO1 or GP2. GP2, it provides predictable burst and baseline performance. The thing that you can specify when you allocate a GP2 volume is the size of the volume. The performance of that is just a function of the size of the volume as opposed to something you specify for yourself. If it's important for you to be able to specify both, then you can go for an IO1 volume, and that'll give you the flexibility to specify either. One other thing to think about when you're looking at which volume type to allocate or how many IOPS or things of this nature is how the throughput of your volume relates to the capability of the EC2 instance that you're attaching it to. So in this example, I have a 6 terabyte GP2 volume, a 2 terabyte with 6,000 IOPS, and that's just math. It's a 3-to-1 ratio between the size of the storage and the number of IOPS you get with GP2. When you look at the volume characteristics, it can actually support up to 160 megabytes per second throughput. So if I attach that to an M4 large, you'll notice that the throughput to EBS on an M4 large is actually only about 56 megabytes per second. So what I want to do is make sure that it doesn't necessarily have to be equal sizing, but make sure that I understand if the EC2 instance that I'm attaching my volume to is less performant or is capable of less throughput than the EBS volume itself, because if my bottleneck is the EBS volume throughput, which in many database workloads that is the case, then I won't be able to benefit from all of the IOPS that I'm actually supposed to be getting from my EBS volume. So we talked a little bit about EBS. The other thing to consider is instance storage. So this is locally attached storage on your EC2 instance. It doesn't have some of the same benefits as EBS because it's not a network attached storage service. It's a local disk basically. So it doesn't have high durability, or it doesn't have, durability is maybe the wrong word, redundancy built into it as a service. It doesn't have snapshot support, and it doesn't have encryption at rest support by default. So these are all things that are solvable, but they would just have to be solved in other ways as opposed to relying on native EBS features to take care of it for you. So why would you use this? Well, there's a couple interesting use cases, and I'll let Veronica tell us about more. The primary use case that we see a lot of is using it for temporary data. If it's not going to be redundant by default, then wouldn't it be great if we had this super high performance storage, and if you lost it, it wasn't a big deal? Well, hey, SQL Server has this thing called tempdb, where that's sort of a square peg, square hole situation. There are use cases where customers want the throughput of that local instance disk for the entirety of their workload, and that's where Veronica is going to tell us more in a few minutes. So I've told you what I think the best practices are. We always like to show you what we hear from customers. So following exactly these sorts of best practices, leveraging EBS storage for backups, Infor was actually able to save about 75% on their storage costs. All right, so we talked about the things at the OS level and below. Now let's kind of look above and how you're actually deploying SQL Server at an architectural level. So if you look at a high availability deployment, sort of agnostic of whether this is AWS or not, loosely speaking, it's going to look like this. You have a primary node, you have a secondary node, and you have synchronous replication between the two. In my previous life, I always like to give anecdotes of my prior life. I worked at a place where we had exactly this, and we had our own data center. So we put one of the nodes in that corner of the data center, and we put the other node in that corner of the data center, keep them as far apart as possible. And that was great. That worked pretty well until the cooling system in the data center broke, and it took out the whole thing. And that didn't really help to have multiple nodes in that case. So that wasn't a great day. So the concept of regions and availability zones, we touched on briefly up front, but within every region, which is just a physical location around the world, we have multiple availability zones. And the nice part of this is that these things are close enough together, 1 to 2 millisecond latency type thing, that you can do synchronous replication between them, and that's going to be performant enough for your application. But they're far enough apart that they're on separate power grids, they're in separate floodplains, et cetera, so that when the cooling system, if that were to happen, gets impacted in one building, it doesn't get impacted in the other building, and you're still off to the races. So this has been really game-changing for a lot of customers, and these kind of capabilities in AWS overall are a big driver of why customers are choosing to deploy this way. So that's great. That's high availability. Some people actually use that prior deployment for both high availability and disaster recovery, taking advantage of the fact that these are separate locations within a given region. Some customers want further disaster recovery capabilities beyond that. So looking at this diagram here, we actually have two regions drawn here. The first region is just like we had in the prior diagram, with synchronous replication between the primary and secondary. On the right side of the diagram, I was just checking if your right is also my right. we have a separate node, and that's being replicated to asynchronously. And that's important just because there's speed of light things when you're going from the east coast of the US to the west coast of the US or further, where you're looking at 50 milliseconds of latency or potentially more depending on where in the world you're going. So generally speaking, your applications won't be tolerant of that sort of latency if you were to do it synchronously. So because it's asynchronous replication, it's a disaster recovery site, you probably aren't going to want to have automatic failovers to that kind of thing, because automatic failover in an asynchronous situation means data loss, and that's just generally a thing that you want judgment involved on rather than automating the trigger. Of course, you want all of those actions to be as automated as possible, but the decision itself should not be one that's automated. And then this is a final slide on always-on availability groups. Distributed availability groups became available from Microsoft in SQL Server 2016. So this diagram really mirrors the previous one quite closely, where within a region, the replication can all be synchronous. When you're doing cross-region replication, that's really a case where you want to do it asynchronously. Finally, we'll talk about failover clusters. So up until now, everything I've talked about was really in the context of something like always-on availability groups. That's database level replication. You don't have to do database level replication to achieve high availability if you don't want to. So some customers, again, sort of comparing why you might use standard edition versus enterprise edition, some customers who can do encryption using EBS's encryption at rest are also looking for high availability options with standard edition. And of course, always-on basic availability groups are available in standard edition. Some customers find that cumbersome to set up, maintain, et cetera, just because it's on a per database level. And what we've seen in a few cases is actually customers doing storage replication to achieve high availability, and then using failover cluster instances to achieve compute redundancy. So there's several different solutions for doing the storage replication. You can use things like Storage Spaces Direct, the new service that we launched just on earlier this week, whichever day that was, FSX. That's also a very viable solution here, and third-party tools like Sios Datakeeper would also be very suitable. So with that, I'll hand it over to Veronica to tell us about her story.
Hello, everyone. My name is Veronica Durgin. I'm a member of the data platform group at Sonos. My team is responsible for managing SQL servers. I've been working with SQL Server for about 18 years. I really enjoy performance tuning and just making SQL Server work in general. By the show of hands, how many of you have Sonos or have heard of Sonos before? Love? Yes? Awesome?
Awesome.
Yeah, thank you. For those of you who have not, we make high-quality wireless audio products. Our products are designed to be modular to fit any size home, and we pride ourselves on being an open system that supports almost every music service and a growing number of voice assistants. Please feel free to stop by after the session and ask me about Sonos. So many of you are already running your SQL servers in AWS. How many of you are here to learn how to run your SQL server in AWS that you don't do yet? Is it okay? Fantastic. How many of you are here because you're tired from all the walking and just found a chair and just want to sit down? So me too. I'm exhausted. We've been running our SQL servers in AWS for about 4 years. We had a fair share of successes and failures and a whole lot of learning. I'm not going to lie, it's been hard. There's so many similar looking options. There are even more options that are strange and unfamiliar. AWS is not your typical grandparents' data center where you get to define physical hardware or ask for dedicated LANs. But I think Theodore Roosevelt said it the best. Nothing in the world is worth having or worth doing unless it means effort, pain, difficulty. As of right now, vast majority of our SQL servers, both OLTP and OLAP, development and production, are running in AWS, and I'm excited to be here to tell you how we did it. When in AWS, do you like the AWSans? I made this up, feel free to quote me. What I mean by that is when you decide to go to AWS, you really need to learn to think differently. In a more traditional data center, we always had to plan ahead. We had to predict growth and usage for the next 3 to 5 years. We had to over-provision in order to invest in the right hardware to make sure that we could sustain growth of our business. The underlying reason for that is because we had to invest a large amount of capital into purchasing hardware, and we couldn't really afford to do it wrong. In AWS, or honestly really any cloud in general, we have to be flexible, agile, and sometimes creative. We have to be aware of the cost and maximize for it. In the data center, we pay up front and are stuck with our choices. In AWS, we pay monthly and have a lot of flexibility to make changes or add additional services. But at the same time, it's very easy for the cost to get out of control if we don't pay attention. And in the words of Spider-Man's Uncle Ben, with great power comes great responsibility. So let's talk about some well-known DBA facts. SQL Server bottlenecks are generally memory and I/O. Whenever we're done troubleshooting those bad queries, and if our SQL Server is performing poorly, we always wish we had more memory and better I/O. We don't generally ask for more cores. Relying on servers not to crash is cold luck, not a disaster recovery strategy. There are many options available to us for high availability, such as always on, and disaster recovery, such as log shipping. And we always test our backups, right? Everybody tests their backups always? Yes. No, you don't have to raise your hands, right? This has been recorded. Because the last thing we want is to have a corrupted backup when we most need it. So our journey to AWS for production loads started on R3 EC2 types. We placed our data on provisioned IOPS EBS volumes. We put our TMDB on the Z drive that was the ephemeral storage that came with R3s. And we used availability group setup with SQL Server Enterprise Edition. We learned many things along the way. Because our IOPS requirement was very high, it was 40,000 IOPS, we had to stripe 2 large EBS volumes together. We also had to go to larger EC2 size in order to get the required optimization throughput. In the end, the setup ended up being really expensive and honestly cost prohibitive for other systems to move into the same setup. But along the way, we also learned that IAM roles make it really easy for us to copy our database backup files to S3 buckets without having to store keys on servers. And we also learned that it's very important that we designed our security groups really well. But I think probably the most important lesson of all was that we had to test, learn, and iterate on our designs. So we talked how SQL Server needs I/O, and I/O is kind of expensive. Wojtek mentioned these wonderful storage-optimized instant types called I3. It comes with ephemeral storage, which is super fast. It also comes at a lower price. But because the storage is ephemeral, it goes away if the instance is stopped. Not when it's rebooted, but when the instance is stopped. And a couple of other things that were also already mentioned before. Starting with SQL Server 2016 Service Pack 1, Standard Edition now has availability group functionality. And there's this fantastic feature that's core optimization or optimized CPU that allows us to disable cores. Therefore, we don't have to bring more SQL Server licenses. All of these features combined enabled us to move all of our production loads to AWS. So this is our current setup. We run I3s of various sizes. They're all set up in availability group setup. We install SQL Server on the C drive. We place TMDB as well as user databases on the ephemeral storage. We've been seeing over 100,000 IOPS and near zero latency. We also copy our backups to S3 buckets, and we have another process that takes the last full backup for every database, restores it, and runs dbcc checkdb on it. But enough with slides. I actually have a video demo for you. I recorded video because video is better because I know it works. And I also cut out all the boring parts. So in my video, I have 2 SQL Server 2016 Standard Edition. The first server is an R4 extra large. I have a 1 terabyte, 20,000 IOPS provisioned EBS volume attached to it. The other instance is an I3 extra large. It comes with about a 1 terabyte of space. So I'm going to run some tests. We're going to check our latency. We'll look at our throughput. And then I'm going to reboot my primary node, failover their setup and high availability setup, failover to my secondary, and run the same test so we can compare. As you're well aware, SQL Server Standard Edition availability groups have limitations, such as you can only add one database to availability group and you can only have one listener. So in our environment, we have this job that kind of mimics availability group functionality of Enterprise Edition. So basically, it works like this. We have a database that we dedicate to be our leader database. It's set up for automated failover and has a listener attached to it. All the other availability groups are set up for manual failover. The purpose of this job is to check if the leader database is on the current node, and if that's the case, it'll fail over the manual availability groups. So I'm going to show you that as well. Let's start. I can start my video. Thank you. All right, so this is I'm connected to my listener. This is the job I just described. It's pretty simple. You just check where the listener, the database with the listener is at, and if it's on the current node, it'll handle failing over all the other ones. So I have 3 basic availability groups. This is my leader one. It has a listener. And the other ones don't. So the script you see in front of you right now, it's a script written by Glenn Berry that helps us check latency on our data files. So as you can see, the latency is super low because I haven't done anything. First, I'm going to run a backup to null. It's a very quick way to check your reads. As you can see, we get about 100 megabyte throughput. Then I'm going to run the actual backup to a file. And this is where I cut out the stuff because it took a little longer than that. So it does about 100 megabytes per second as well. So let's check our latency. And as you can see, the latency had gone up. So next, I'm going to use this free tool available to everybody, SQL Query Stress Tool. It allows you to run a query multiple times, and you can define how many parallel threads you want. So I'm going to connect to my listener. Clean my buffers, and run this query. So it actually took about 10 minutes. All right, so let's check our latency. The latency is about the same. Hadn't changed much. All right, let's reboot our primary node. So remember, the first primary node was an R4 with an EBS volume. So we're going to restart it and see what happens with the failover. All right, let's connect to the secondary node now. I'm connecting through the listener. And we're going to run, let's check availability groups. As you see, the automated one failed over, but the other ones hadn't. So normally in our environment, this job runs every minute on every node. So it's kind of like it's not quite as beautiful as Enterprise Edition, but Standard Edition much cheaper. So you kind of pick and choose. All right, and as you can see, all the availability groups failed over. All right, so we have our backups. And we have our query. So let's check our latency. It's 0 because I haven't done anything on the server yet. Let's run backup to null. 1.4 gigabytes throughput. Remember 100 megs on R4? 1.4 gigs. Super exciting. Let's back up to a file. All right, not as exciting, but still really good, about 400 megs. Let's check our latency. 4.1. Remember it was almost 40 on the other server? This is pretty awesome. I'm excited. Everybody excited? All right, let's run our SQL Query Stress Tool. Clean buffers, even though there isn't anything in buffers, but why not? All right, it takes about 10 minutes. So, quick summary. As you saw from my demo, i3s have quicker reads, quicker writes, and very low latency. I actually also ran disk speed tests on the same servers, And it wasn't a very exciting thing to show you, but I'll show you the output. If you look at this table carefully, you'll see that the output is pretty consistent with what we saw in the demo, where the reads are about 10 times faster on an i3 versus an R4 with EBS volume, and the writes were about 4 times faster. You are probably wondering why I showed you SQL Query Stress Tool, because it ran 10 minutes on both servers. So my initial intent was to write this really bad query and see how it behaved. Turns out that it's really hard to write a bad query on purpose. I write them by accident all the time, but on purpose it's really hard. But I wanted to leave this in my demo because I want to tell you that it's very important that you test your systems with your actual loads if you want to make sure that you arrive at the right conclusion for your environment. We're actually running a hybrid environment where while many of our servers are running on i3s in availability group setups in both Enterprise's Standard Edition, we also put archive of barely used databases on GP2 volumes. We use core optimization a lot. This was a fantastic feature. We've tested disabling hyperthreading versus disabling cores, and disabling hyperthreading actually yields 30% better performance than just disabling cores, so we try to use that where possible. We utilize SQL Server replication in our environment. As you well know, distribution database does not have native high availability capabilities, so we actually use an M3 with reserved IOPS EBS volumes because of their durability. For our analysis services, we use memory-optimized X1E instance, and we put our backups to S3 buckets for offsite storage. One thing worth noting is that make sure that you have retention policy on your S3 buckets. You can do it either through S3 lifecycle policy or on your own. For our backups, we prefer to do it on our own because we never want to delete the very last backup in any S3 bucket. So I've said this before, but I want to stress it again. Understand your loads and stress test your environments. Understand your IOPS and your throughput. I showed you Glenberry script, I showed you SQL Query Stress Tool, as well as the output from disk speed test. There are many tools available to us that can help us create baselines and stress test our systems. Use core optimization where possible. Make sure your security is well defined. Make sure you always test your backups. Design your systems in such a way that it's easy to make changes and automate whatever you can. AWS is extremely powerful and very versatile, but a bad decision can make for a very bad experience. I want to conclude my presentation with this very wise quote from LL Cool J. Once you achieve one goal, you should be looking forward to trying to build onto the next thing and not just getting comfortable with what you're doing. Never be content with what you've built. Look outside the box to see what else is available. This is absolutely not the end of our journey. We're always on the lookout for new features coming both from AWS and SQL Server. They can help make our systems better performant, more resilient, and more cost efficient. Thank you.
Awesome. Thanks, Veronica. Again, selfishly, I'm super excited to see the cool stuff she's doing because I have so many Sonos speakers at home that I feel like I've invested in a great company. So let's summarize some of the tips and tricks that we've talked about both in my slides as well as Veronica's so far. Test, test, test. Maybe this hasn't been as big a theme of this presentation as we intended, but it's cheap and easy, and it's one of those things where when you're in your production workload and something went poorly, you don't want to be diagnosing and debugging these things for the first time. So understand where your bottlenecks are, do that kind of stuff proactively, and that'll help you understand some of the sharp edges of what may exist in your system and how to recover them when you actually need to recover them in a production system. Obviously, for high availability or for production workloads, use a high availability deployment. One of the things or a couple things to keep in mind is to leverage your free failover rights. So if you keep all your databases on the same primary node, then your secondary node you don't have to license. So that's a pretty significant cost savings in many cases. The other thing to think about is to isolate your network traffic between what SQL Server needs to replicate from primary to secondary versus what's coming in from customers. So if those things are running on the same ENI or network adapter, then you may actually run into contention there. So it's better to separate those two things out to make sure that you're not contending or you're not accidentally backing up one for the other. Backups and audit logs to S3. So S3 is obviously a hugely durable solution. So that's where we recommend all customers kind of put that kind of stuff. Nightly backups is generally what we see customers do, nightly backups or daily backups, and then log backups after that for the ability to do point-in-time recovery. The nightly backups that you're doing, you actually have a couple options there. You can do SQL Server native backups, or you can actually do storage snapshots. So if you freeze I/O, you can take storage snapshots. SQL Server is crash safe, so those storage snapshots are actually viable backups for your database. And then newer instance types are generally faster and cheaper. This is very true. We've certainly seen it internally from our benchmarks running R3 to R4 to R5 tests. EC2 did some really great work with the Nitro system in the latest generation of instance types, where we're offloading a lot of the compute to separate hardware, which is freeing up more capacity and actually creating a much more performant experience on the latest generation of instance types. So let's talk a little bit about RDS for a minute. So we talked about what does high availability or multi-AZ deployments look like in general for SQL Server. Well, in RDS, they don't look any different. But the thing to keep in mind when you're doing this in EC2 is that you design your system, it's going to have automatic failover, so if something bad happens, you're covered. So that's what happens. At 2 in the morning, you get your page or your phone call or whatever. Your primary node went down, so you panic, you log in, you check, and the failover worked. Everything is happy. The application experienced whatever failover time, but it worked as designed. Fantastic. But you can't quite get back to sleep because you're not highly available anymore. You've only got your primary node. So ideally, you have automation to be able to create your secondary node. I know Veronica's got a whole bunch of that stuff, so hopefully you're building that kind of stuff. But it's the thing that you need to make sure you're aware of, that after you design this thing, you've also got to deploy it, but then manage it when these things do strike. So RDS takes care of exactly these kinds of things. So again, I mentioned a little bit up front about the undifferentiated heavy lifting. Rebuilding a secondary node or repairing it or bringing it back to health in whatever capacity after a failover, that's exactly the sort of automation that RDS does. In addition to that, I listed out a few tips and tricks. So things like high availability. These aren't complex configurations in RDS. It's literally a single parameter. You pass a multi-AZ flag that says true. We set up that high availability architecture behind the scene, and we manage it to make sure it stays highly available. Backups and audit logs to S3. All RDS backups go to S3. That's where they live. Both the nightly backups, those are actually EBS volume snapshots. That's why I mentioned that earlier. And then we also put audit or your log files there as well. Newer instance types are generally faster. And then the last one that I want to call out is the sort of benefit from the army of people using RDS. So RDS has hundreds of thousands of customers. We're doing backups. We do backups at least once every 5 minutes for every database instance that we host. So we're literally taking log backups of databases millions of times per day. What that means is that when there's an edge case that you're thinking about and you're like, well, that's like 1 in a million. That's not a big deal. For RDS, when we think about 1 in a million, we're like, oh man, that's going to be a really big problem because it's going to happen all the time for us. So we've got to be automating around these super sort of obscure edge cases, which it doesn't really make sense for an individual customer. Like Veronica's got some really cool stuff. It doesn't make sense for her to solve for every 1 in a million condition, whereas RDS really has to. So in general, we offer the best practices sort of done for you in a managed way. Now let's talk about how do you migrate databases to Amazon in general. The way you move data around in your current configurations is probably the simplest and easiest way to do it. You take your native backup file and you restore it. You can do that in EC2. You can do that with Amazon RDS. The difference with RDS is that you can't do differential restores. So it's really, with native backups into RDS, it's a one-time ingestion, and then you'll have to find a way to ingest incremental data if that exists at some point later. Which brings me to logical replication. So we have a tool called Amazon Database Migration Service. This is a logical replication tool, which under the hood uses change data capture. So you could actually pair native backups and then use a differential restore point and catch up the incremental changes using something like Database Migration Service, or of course you could use CDC natively under the hood if you preferred. This is a highly robust tool. It's actually moved over 90,000 database instances, and it's interesting because it's database instances. So, how many databases do you have on a given database instance? Dozens. Sometimes people tell me hundreds. So the number of actual databases migrated is actually quite a bit larger than this. We built this tool for migrating databases both like to like. So in the case of migrating an on-premise database into AWS, but also to migrate across database technologies. And that's where the schema conversion tool comes in. So this is a tool that will automatically translate your schema, as well as any sort of stored procedure type things that you have in addition to that, into your target database of choice. So this is a nice tool because it converts what it can, but it also provides you a nice report to tell you what it couldn't convert. And that's where you would have to do additional manual work sort of on top of that. So let's look at the use cases for it. So the first to use the database migration service, sometimes we joke internally that we really should have called it the database replication service, because that's what it does. And we've actually added high availability options to it because we saw so many customers were using it for exactly that. So just to do cross-region read replicas, for example, that's not a capability supported today in Amazon RDS. So we found people doing this. The one sort of thing to call out about the database migration service is that one of the endpoints that you're migrating to or from has to be in AWS. So you can migrate in, you can migrate out, whichever way, RDS or your EC2, it doesn't matter. But one of the endpoints does have to be in AWS. The next thing we see it being used for is sort of migrations, to migrate specialized workloads out to a more specialized data store. So things like Redshift, or even in some cases, things like DynamoDB or others. And then the final use case that we see is to actually modernize database applications. So we talked a lot about licensing. In every customer conversation I have around SQL Server, licensing is a topic of conversation. So we do see customers looking at options for migrating to non-commercial alternatives that have similar capabilities that aren't as costly. And Aurora is one that really comes to mind there. So you've got your database, you've migrated it in. Now, how do you know if it's performant? So we have a service called CloudWatch, and this lets you collect, monitor, react, and analyze your data. So what can you collect? There's a list of sort of default metrics on the right there. RDS metrics into CloudWatch, they go once per minute. EC2 metrics can be configured down to once per minute. These are infrastructure level metrics, so they're captured from the hypervisor. I'll talk on the next slide about why that distinction is interesting. Once you have your metrics there, you can monitor them. So you've got monitoring tools in place already. I'm sure this is one that you can use where you can make sure that you're not down to a critical threshold of free space, or if you're not consuming more than 90% CPU, or the relevant things for your workload. You can set up automation for how to react. So in the case of you're consuming all of your storage, you can actually trigger a Lambda function to automatically grow your storage volume, if that's what you would like to do. You can also just call yourself or page yourself or whatever else. What if you want something a little bit more in-depth, a little bit more granular? So we have a couple options for this right now. And actually, for the EC2 side, we announced some pretty exciting enhancements to this earlier this week with integration with SageMaker and a couple other services. So if you want to have granularity down to the second in RDS, we have a feature called Enhanced Monitoring. So this is just both of these solutions, the RDS one and the EC2 one here, are agent-based solutions where there's an agent running on the box, offloading stuff as frequently as you would like, down to 1 second. So that's really helpful. 1 minute granularity, you can miss some things. 1 second granularity can be very helpful. So I mentioned that this is an agent-based thing, so you're actually getting metrics as observed from the instance as opposed to as observed from the hypervisor. So when you compare these two things, there might be slight differences, and that's really the explanation why. One last thing that I'll mention that I don't have on the slide here is in RDS, we actually have a feature called Performance Insights. And this kind of goes the next level down. So the monitoring we're talking about here is process level monitoring. The Performance Insights tool is a tool that's available today for every engine in RDS except for SQL Server. We hear a lot of requests for it. It actually provides visibility into the database itself. So you can see things like which queries are taking longest. It's really the deeper view into the database that helps diagnose where your time is going. What about security and compliance? We talked a little bit about security in the context of geographic deployments, but there's obviously more to that. We have a shared responsibility model for security, and this changes slightly between RDS and EC2, so I'll go into some of those distinctions. we are responsible, we being AWS, are responsible for everything up to the host operating systems in all cases. In RDS, we actually have more responsibility because we don't give you root access to log into the box. So we're also responsible for the operating system. We're responsible for host access. We're responsible for patching the operating system when appropriate. The other thing that we control in RDS is how the database gets patched. So when the next service pack or CU gets released, we will make that available, and we define the automation that applies that patch, but you decide when you actually want to apply the patch. In terms of things that you manage for security, it's all the things that you commonly think about. Your users, you can use things like Windows authentication, encryption, auditing, etc. Let's get a little bit more into encryption. I know we've talked about it a few times here. There's two options for encrypting your data at rest. They are really functionally equivalent, that there's not one choice that's more secure than the other. They're both equally secure. So you can either use the Enterprise Edition feature, transparent data encryption, or you can rely on EBS's native encryption. And then the other thing to think about is how to encrypt your data in transit. So of course you can set configuration to force all connections to be SSL, or you can do this per connection. Auditing. Again, there's two things to think about for auditing. One is what changes are being made to your database resources, and then what changes are happening inside of your database resources. So when a user provisions a database or modifies it in some way, from one of the AWS APIs or AWS consoles is sort of the way to think about it. That's an important event. You don't want to have rogue operators deleting a database or something of that nature. So you want to make sure you're looking at your CloudTrail logs to understand what's happening there. And then inside of the database, you want to use server or database level audits, whatever is important for you, set up the appropriate retention periods, etc. And these are all things that are responsibilities that, of course, you maintain. And then finally, compliance. We have always regularly people coming up to us and saying, what kind of compliance solutions do you offer? In general, we have solutions across finance, healthcare, government, industries. So we think we have you pretty well covered, but there's a link up here on the slide if there's a specific designation that's important to you. All right, we made it through. You now know how to design, migrate, and deploy databases on AWS. So we've got a few more minutes for questions. Please complete the survey before you go or after you go. Thank you for your time, and if you have any questions, we'll be happy to take them now.
Instance type, when you're purchasing it as you're provisioning it to start up, do you buy the Windows with SQL Server, or do you bring your own license?
So you can't bring Windows Server. Windows licenses you cannot bring. You can bring SQL Server licenses.
That's what I mean.
Yes.
So that you can shut off some of the
cores. Yep.
cores. But so you can only do that when you bring your own SQL Server license?
Yes.
Yes.
Okay,
Yes.
all right.
Yes.
So is your i3 instance only your secondary instance, or?
No, they're both primary and secondary, but they're all in high availability.
So how do you protect the user databases that are on ephemeral storage? What happens if you have to stop an instance? You just make sure you fail over?
Yeah. So definitely, if you go with i3s, don't have just one instance. Always have very solid, high availability or disaster recovery plan. And it's not on reboot, it's fine. It's only when you have to stop. And periodically, AWS sends you emails saying, oh, by the way, you have to stop your instance because we have to migrate storage. So it happens.
We've had instances become unresponsive.
Yeah, it absolutely happens. But it can happen to any instance type. Yep.
The tool that you created for failover for is that available?
The job that we have?
Yeah.
We just custom wrote it. You can we actually it wasn't even our original idea. We Googled it and just searching and got an idea. I will try to add it to the slide deck. Okay. Slide deck will be available. Yeah. So I'll contact AWS to make sure that the script is there as well.
Not that we've The only impact that we've observed from an RDS perspective is actually encrypting logs on the way out, because we want to be able to encrypt both the storage volume and the logs, but otherwise, no.
And we actually also tested EBS encryption at rest, and we didn't see any performance difference either. We actually back up locally, and then we copy backups to S3. Yeah. So I will tell you that, and again, it depends where you put your backup files. If you back up to ephemeral storage, you can take like a 2 terabyte database. It ends up with like a 600 gigs file. It's about an hour and a half. So we've been actually able to run backups more often. But if you run out of space because you're limited with how much space you can get, then you can start looking at SD1 or GP2. Those are slower. So you'll have to adjust your backup strategy.
So just to be clear, as far as your data protection goes, you feel like having 2 copies of the ephemeral storage is really solid protection? You don't, I'm just thinking about the big question right before.
It's certainly risky, and I know it's like it's the comfort level. But honestly, there's nothing guarantees you from your data not being corrupted on the EBS volume either. So you always have to have solid, high availability or disaster recovery plan regardless where you go. Obviously, I3s are risky, but it's high risk, high reward. You get fantastic, IOPS and throughput. But it's certainly not for everyone.
Do you write any kind of statement or explanation to give to your management and customers about explaining the risk and the trade-offs?
I mean, we certainly talk to our CIO, yes. Yeah. So this is custom made by my boss. That's pretty cool. Thank you. We're all about music.
All right, I think we're going to get kicked out of the room, so we're happy to take sort of questions maybe here or outside the door as the facilitators guide us. Yeah, thank you.
Thank you.